mu they have given as 2, 1. 2, 1. It's not 21. You notice. What is 2 and 1? Refractive index of the second medium with respect to the first medium. Understood, no? First medium is from where the light is coming, and the second medium is where the light has come into. So if it is coming from air into glass, which is medium 1, air is medium 1, and glass is your medium 2. So if I write it as refractive index 2, 1, it means that it is the refractive index of the second medium with respect to the first. Are you okay? Did you understand? Okay, fine. Look at this one. Yeah, yes, yeah. Fourth one. Experiment to not this. Not that.
From second to second.
Okay. Right. This is all we need. We have taken ABCD. I'll do a little bit of fast forward. See, you have drawn the outline. You have drawn the line. Angle of incidence we can take anywhere from 30%. Now he has already taken a specific angle. He has taken 35 degrees. Right? He's taken 2 pins and you're going to stick it on that. See, that red one is nothing but a pin. You're stuck it. Now you're keeping the gas lamp back again. Let's see what is going to happen. Light is going through the glass lamp. Now we are going to bend down. This is where I want this. I'm going to bend on this side and put 2 more pins such that it appears to be in a straight line. But will it be in a straight line? No, it will not be. It is appearing to be a straight line. So once again, you are taking out all the pins and you are drawing, connecting all the lines. So this is what it is. Now we are going to draw the normal. Right? That's the first refraction, the second refraction. And what did we find? That it has moved. Now you're going to draw the dotted line. He's drawn a straight line, but it is a dotted line. Did you notice this? Okay. So angle I is 35. When you're writing angle E, it is also 35. And these two will be parallel to each other. Got it? For homework, practice this diagram. Another question. Come on, quickly. On a neat monthly page, I want you to practice this diagram because it is definitely going to be asked. Did you see what is lateral displacement? It has moved, it has shifted. That is the lateral displacement. They are taking different ratios to show you what is happening. That understood? Okay, fine. Refractive index. Come there quickly. So the first sentence we have already seen. What is happening? Ray of light travels obliquely. And once again, please remember the word obliquely. Underline the word oblique. From one transparent medium into another, it will change its direction. Why is it changing the direction? Why is it changing? Because I don't like to travel in a glass slab. Is it that? Correct. Because the speed of light is changing. The speed of light will not remain the same. Remember that. Okay? Then, in a given pair of media expressed in terms of refractive index, the constant. What is the constant here? Mu is nothing but the constant. It is the refractive index. Are you okay? Right. It can be linked. Second paragraph. Question the refractive index can be linked.
The refractive index can be linked to an important physical quantity, the relative speed of propagation of light in different media.
Pause. What is important here? Read the sentence
Physical
again.
quantity.
What is important here?
Propagation of light.
Propagation of the speed of light. Underline that. Second paragraph, second line. Relative speed of propagation of light. What is relative meaning? We are comparing relative speed of the light in glass and speed of light in air. Next.
It turns out that light propagates with different speeds in different media. Light travels faster in vacuum with speed of 3 into 10 raised to 8 meter per second. In air, the speed of light is only marginally less compared to that in vacuum. It reduces considerably in glass or water. The value of the refractive index for a given pair of media depends upon the speed of light in the two media as given below.
So the table, of course, we have seen. Consider a ray of light traveling from medium 1 into medium 2. Okay. V1 is the speed of light in the first medium, and V2 is the speed of light in the second medium. The refractive index of medium 2 with respect to the refractive index of medium 1 is given by the ratio. So when we write it as refractive index 2, 1, it means it is the refractive index of the second one compared to the first is equal to V1 divided by V2. What does V stand for? It is velocity. So which means to say it is velocity of light in the first medium compared to the velocity of light in the second medium. What is first medium? Air. And what is the second medium? It is nothing but glass. Is that okay? Is that okay? Did you understand? For example, I'm talking about V1. Okay, V1 is the velocity of light in the first medium. I want to talk about V1 being air. And what is the value? It is 3 into 10 raised to the power of 8 meters per second. What is V2? It is the velocity of light in the second medium. Now, second medium happens to be glass. In glass, obviously, it is going to reduce. We have seen that. So, let us say the value is 2 into 10 raised to the power of 8 meters per second. Okay. I'm going to use these values to find out what is the refractive index. So, refractive index of the second media with respect to the first. That is, I'm finding out what is the refractive index of glass with respect to air. I'm going to substitute the values. 3 into 10 raised to the power of 8 meters per second divided by 2 into 10 raised to the power of 8 meters per second. What happens to the unit? It get cancelled out. Okay. So refractive index has no unit because it's only a ratio. Any ratio will not have any unit. Okay. What is left behind? This is also getting cancelled out. 3 by 2. How much is it? Okay. Very good. So refractive index of the second media with respect to 1 is 1.5. See your table. Ground glass 1.52 something. समझ में आया? Did you understand? Take down this sum quickly. Calculate. I'm giving you the sum. Take it down. Calculate the refractive index of glass if the speed of light in glass is 2 into 10 raised to the power of 8 meter per second. Okay. In most of the sums, they will not give you V1 because air you are supposed to know. Okay. How will you do? This is the data which is given. Write down V1, which is the velocity of light in air. It is 3 into 10 raised to the power of 8 meter per second. This is also given, V2 is given to us in the sum, which is 2 into 10 raised to the power of 8 meter per second. Then you will write down the formula. No, you have to write required to find. What should I find? What is asked in the sum? To find the refractive index. Yeah, to find refractive index of glass. This is what I have to find out. And what is the symbol that we are using for refractive index? Mu.
How do you write the spelling of the
Mu. Sometimes, in some of the textbooks, they also give you as this. That's a Greek alphabet. Mu. This is mu. Accepted. In some, many of the books, they'll also write it like this. That's also possible. So that's why I said I want to check out the CBSE. They keep on changing. This is also accepted. But we will stick to whatever is given in your textbook. They are given this way, so we'll stick to it. Next, you will write down the formula. Formula, write down this. Show your calculation. Remember, refractive index has no units because it's a ratio. Are we okay till here? Now, if you look at the chart that they have given, did you see refractive index? There is no unit there. Make a note of it in your textbook itself. Make a note. No units for refractive index because it's a ratio. Okay. Now, my second question. Right? What if I'm asking you to find out the refractive index? Okay, here what did we write? 2, 1. If I write it as 1 and 2, what does it tell us? It is the refractive index of the of medium 1 with respect to 2. What will I do? Exactly, we'll just switch. This will go that way. That's all. Don't get confused. Understood now? Refractive index of the second with respect to first will be whenever this one. If I'm asking you refractive index of the first with respect to second, this will be inverse. Okay? Look at your textbook. 9.6. 9.5, 9.6. Did you see that? 9.5. N to 1. Speed of light in medium 1 divided by speed of light in medium 2. V1 divided by V2. Same thing. Either. Okay. Okay, ready, all of you? Look at that one. Same argument, the refractive index of 1 with respect to 2. How will you show it? Mu 1, 2. It is refractive index of 1 with respect to 2. And how is it given? It is given by V2 divided by V1. Is that okay? Yeah. Okay. Please make a note of it. Write down. Not a sum or anything, just to remember. Refract, ये लिखो पहले. Refractive index of first media with respect to the second. You will write it as velocity of light in the second media with respect to the velocity of light in the first media. Remember this. And this is going to be inverse of this. Samjho? Okay? Now, I am rubbing this up. Okay, till here we are okay. So far I have been talking about refractive index V1. What is V1? Yes, anybody, what is V1? Velocity. Velocity of medium नहीं. Velocity of light.
Medium.
Don't make a mistake. We are talking about light which is moving, not velocity of the medium. Medium is not moving. समझा ना? So the words are very important. Velocity of बोलो light in medium 1 with respect to 2. What if medium 1 is not air and let us say it is vacuum? CC of C into N. Okay, what if it is vacuum? Is it vacuum? CUN. And this is, let us say, whatever it is, it's glass or whatever it is. Here we can put it as C, that's all. Okay, so you see that if it is velocity of the second medium with respect to, let us say, vacuum, instead of writing V1 divided by V2, I just write it as C divided by V2. You understand? Did I put 1 there? I have not put 1. That means this is the absolute refractive index. What is the meaning of absolute? Because we are talking with reference to vacuum. Got it? See the last line there? If medium 1 is vacuum or air, mostly it is vacuum, then the refractive index of medium 2 is considered with respect to vacuum, and this is known as the underline. Absolute refractive index of the medium. How are we showing it? Only by doing this randomness. All of you please make a note. Absolute refractive index in your notebook. We are not putting any medium there. Okay, so instead of writing V1 by V2, what are we writing? We're just putting it as C, that's all. What does C tell us? It is the speed of light in vacuum. Go to the next page. Yeah. Yes. No, it is in air. You find that it is how much? Okay, then. Luckily, it did not fall on my dress. Okay. Air, how much is it? Not 3. Refractive index is only 1.0003. In vacuum, it is just 1. Very similar. So for all practical purposes, it's the same value. Okay. Did you mark it? What is absolute refractive index? Everybody has marked it? There. Did you write down the formula there? 9.7. Noted it down? Because based on this, there will be quite a few sums coming up. The absolute refractive index of a medium is called its refractive index. Did you get this paragraph? The refractive index of several media is given in the table. Of water, NW is 1.33. What does it mean? Where is the speed of light? Suppose I give you 3 materials. Put a question now. Let me ask you a question. Okay. I've got 2.54, I think is diamond. Correct? And I've got 1.42. 42. Okay. 2.42. Then I have, let us say, 1.33 is water. Correct? And let's say I have 1.52, which happens to be ground glass. Okay, this is diamond. Now my question is, arrange this material. Get down, everybody. Arrange this, what about this? In the increasing order of the speed of light. Accordingly. Arrange these 3 in the increasing order of speed of light or velocity of light. Chalo, good. What is increasing order?
So from smaller to bigger.
Correct. So first small, then I want you to arrange it in this order. You do your work, don't ask. Let everybody do. Quick, it should not take more than 1 second. I've given you 3 values. Okay, finished? Yes.
Water glass. Diamond glass and
Yes.
water.
Got it? Diamond value is what? 2 point. That means if the refractive index is more, speed is less. So पहला आएगा diamond. Then the rest of course you will understand. Understand. So what does it tell you? Inversely proportional. Refractive index, if it is more, that means the speed will be less. Got it? I'm just giving you different.
Like if just in decreasing order, so first will come.
Yeah, obviously, if it is decreasing order, बड़ा पैदा आएगा, बाद में this way. This is your decreasing order. Increasing, decreasing. Glass anyway will be in the middle. So it's only the difference between your, yeah, these two. Okay, such type of questions you can expect for your exam. Increasing order, decreasing order. Sometimes they will give you light and they may ask you for refractive index. They may give you refractive index and ask for light and so on. Just below the table, please see. Note from table 9.3 that an optically denser medium may not possess a greater mass density. So we are not talking about mass density. Underline this word very carefully. Okay, for example, they're talking about 2 substances. Kerosene, having a higher refractive index, is optically denser than water, although its mass density is less than water. Look at the table. Kerosene ka value kya hai? 1.44. Okay, so kerosene value is 1.44. And what about water? 1.38. Did you notice? Refractive index of kerosene is more than that of water, but the mass density is not. So in refractive index, whenever we are talking only about optical density. Don't get confused, it's not mass density. That's a point to remember. Okay. Do you know? Look at that box very carefully. Ability of a medium to refract light is also expressed in terms of its optical density. Anush, are you paying attention? Which one? Where are we reading? Read.
The ability of a medium to refract light is also expressed in terms of its optical density. Optical density has definite gravitation. It is not the same as mass
Underline.
density.
It is not the same. Next.
We have been using the terms rarer medium and denser medium in this chapter. It actually means optical rarer medium and optical denser medium, respectively. When can we say that a medium is optical denser than the other? In comparing two media, the one with larger refractive index is optically denser medium than the other. The other medium of lower refractive index is optically near. The speed of light is higher in a rarer medium than a denser medium. Thus, a ray of light traveling from a rare medium to a denser medium slows down and bends towards the north. When it travels from a denser medium to a rarer medium, it speeds up and bends away from the north.
Now this is your answer. Many times they will give you why the bending is taking place. So use these 2-3 lines there. Okay, mark it as important. I want you to use these sentences when you write your exam question. What happens? We have to explain it in terms of speed of light or the velocity of light. Did you make a note of it? Okay. Now for the next class, I want you to all get your geometry box because we'll be once again doing a whole lot of ray diagrams. Look at the ray diagrams coming up here. Get your geometry box. Now we'll be starting off with convex and your concave lenses, not mirrors. Okay. So right now I'll be talking about refraction of spherical lenses. Give you a little bit of introduction. In the next class, a whole lot of diagrams coming up. Look at the questions here. In-text questions. Ready? Ray of light traveling in air enters obliquely into water. Obliquely. Okay, it's not on the normal. Does the light ray bend towards the normal or away from the normal and why? What's your answer? Homework. Put a tick mark. Homework. Bolo, bolo, answer bolo. From where to where? From where to where? See, from which medium to which air? From air to water. Very good. From air to water. Towards. It is bending towards. है ना? Air से आगे आप glass slab में it is bending towards. Air से आगे water में it has to bend towards. And why is it bending towards? Because the speed of light decreases. Decrease or increase? It has to decrease when it is coming into water. Will you be able to write that? Remember? Put a tick mark. Okay. Next one. Light enters from air to glass having a refractive index of 1.50. What is 1.50? Refractive index of what? Of glass. Okay. What is the speed of light? Mu of 2, 1 is equal to V1 divided by V2. What is given? 1.5 is given here. Okay. Do we know V1?
Yes.
What is V1? Correct. Meter per second. What should we find out? We have to find out V2. Can we rearrange this formula? Therefore, what will you get? V2 is equal to how much?
2 into 10 raised to 2.
That is because you have this one, right? So what will come here? You will have this here and this will come here. So it is 3 divided by 1.5. That will be 2 into 10 raised to 2. Just a rearrangement of your formula. Right? Third one. Find out from table the medium having the highest optical density. Find out the medium with the lowest optical density. Bolo kya hai? Diamond is how much? 2.5. Next is 1.0. Okay, fine. You are given kerosene, turpentine, and water. Okay. In which of these does light travel fastest? Look at the refractive index. What are the 3 things given? Kerosene, turpentine, and water. Fastest in water, kerosene and turpentine. Turpentine will be slowest because it is 1.47 and the other one is understood? So such type of questions can be asked. Then look at 5. Refractive index of diamond is 2.42. What is the meaning? Anish, what is the meaning of 2.52? What does it tell us? Look at the formula, maybe you can get some hint. If I give you a number here, what does it tell us? Right. If you're wrong also, I'm there to correct you, no problem. You should all try. Yes. Ratio of object. Here they have given as a diamond. Okay. So, come on, try. It is the ratio of the speed of light in. Are they given as absolute? No, they're not given absolute. So you can take it A. Okay. Of the second media with respect to first is 2.5. What does it mean? Is it faster? Is it slower? Slower. Yeah, so you should write the speed of light in diamond is slower by a factor of Factor of how much? 2.2. Did you understand? How did you write? Make a note of it.
Slower and factor of
Slower by a factor of 2.4. Understand? Okay. So I want you to do first one. The others we have already done it in class. Plus homework of glass slab, definitions, Snell's law, all that you have to learn at come. Okay? Come on, leave a page. For your diagram and all, please leave a page. Refraction by spherical lenses. We will start. But of course, what are the two type of lenses we'll be talking about?
concave and convex.
Concave and convex. Now, since we have done mirrors, this will become very easy because more or less the terms are going to be very similar, except for a few differences. Now, here it is a spherical lens. What is the meaning of spherical? Sphere. The word spherical comes from the word sphere. This is a sphere, right? This is also a sphere. So if I am talking about a convex lens, it has got two curved surfaces. And these two curved surfaces obviously belong to two different spheres. So that's why it's known as a spherical what? Lens. Don't talk about mirrors. So this is your convex, which has got two curved surfaces bulging towards the outside. Now if I'm talking about a concave, so what will happen? You have one here, and I'm talking about a concave lens. So it may be something like that. Maybe of the same diameter, it may be of a different diameter. Okay, so what we are concentrating is on a concave lens which has got two curved surfaces. These surfaces are curved towards the inside. So basically, we will be talking about two things. So you will have two centers of curvature. Do you understand? In the mirror, it was only one. Suppose I take this part and let us say it is a mirror. So I'll have only one center of curvature. But in a lens, we will talk about two centers of curvature because there are two surfaces of the spheres which are taken involved. Are you clear about it? Suppose you are talking here, a refraction taking place. Remember that all the rules that we have learned will be the same. Now, for example, if you are talking about a convex lens, this is O, which is the optical center. Optical center, just like your principal axis. Now, this is your optical center, and we have got the principal axis, okay, which is an imaginary line running through O. Now, what is happening is, let us say we are talking about rays of light. After passing through the lens, it is a converging lens. Converging is what? Meeting. So you have this ray of light which is meeting. This is your converging lens. A convex lens is a converging lens because it is meeting at a point. Has anybody used a convex lens before? Do you have a convex lens? You have microscope, but you have a handheld magnifying glass. Anyone? You have? I'll get one next time. Okay, I'll show you. Okay. So how is it when you see it is thicker in the middle and towards the edges? Obviously, it is getting thinner. Right? So that is a convex lens. If you notice, this is exactly opposite. Isn't it? It's thinner in the middle and it is bulging out. It is thicker towards the edges. So that is your concave.
In cameras also convex lenses.
Sorry, where?
In camera lenses convex.
Yes. Yes. We are using convex lenses. Okay. Also, we will talk in detail regarding, none of you have specs, so you may not know. These are nothing but lenses. Okay, so if you are you have, where's your lens? Sitting at home. Are you okay? Can you see? Or is it looking blurred?
Little.
Then why don't you wear it? You look like a scholar. Okay, so we use such type of lenses. It may be a concave lens or you can use a convex lens or depending upon what type of power you have. That we will do it in our next chapter when we go about the human eye. That's also very interesting. So what type of a lens is that? This is a convex lens. See, it is a convex lens. And what does a convex lens do? It is converging the light rays. Are you okay? What happens with a concave lens? So we are having a concave lens. I'm drawing a very exaggerated diagram only for you to understand. Okay. We are taking O as the optical center. I'm drawing a dotted line. One ray, but it is diverging, which means to say the ray after refraction is moving away. It is moving away. I'm talking about the other one. Once again, it is moving away. But if you extend this line behind, it appears as if it is coming from a point. Okay, that we will see when we start drawing our ray diagrams. So what type of a lens is this?
Concave.
Concave lens is a diverging lens. Converging lens and a diverging lens. Are you familiar with these two words? No. Apart from this, of course, we need to also know something more about the terms that we are going to be using. So remember this. So what am I going to do with this lens? Okay. I'm just drawing a dotted line for us to understand that this is a part of the sphere. Did you notice it's a part of a sphere? So this is your center approximately of the sphere. Okay, so this is your center of the sphere. Did you notice what happens to the focus? It is half of that. To draw it accurately, your focal length, this is your focal length F, which is going to be half of the radius of curvature. Is that okay? Yeah. So if you look at the ray diagrams, which is drawn here, see the ray diagrams. You will notice there is an F1 and an F2. Did you notice? F1 and F2. So there is the first focus and there is the second focus. Why two? Because there are two spheres. So this is one sphere and the other sphere is on this side. Similarly, we'll have C here. So you will have an F1 here and you will have an F1. You will have a C1 here and a C2. Is that okay? Yeah. Now before we actually go on here, we will read a few of this page. We have got a lot of uses of convex and concave lenses also. And as we keep on reading it, we will understand. You must have seen watchmakers using a small magnifying glass. Have you seen? They put one small thing near the very end. I don't know, you not seen? Never gone to a watchmaker, they usually do. When you go to the market next time, they will be small thing they'll put and see what is there. Because the parts of the watch are very minute. So obviously they need to have a magnifying glass. Okay? Have you ever touched the surface of a magnifying glass, the glass used in spectacles? What is a lens? How does it bend? These are the things that we are going to discuss now. Okay? Read better. A transparent material. Second paragraph.
A transparent material from fiber surfaces, of which one or both surfaces are spherical. From a lens, this means that a lens is bound by at least one spherical surface. In such lenses, the other surface would be plane. A lens may have two spherical surfaces bulging outwards. Such a lens is called a double convex lens. It is simply called a convex lens.
Okay, pause. What did they say about two? What is this? Both the surfaces are bulging outside or it can be bulging inside. What did they say? Maybe one of them can also be a plane. Can you see that? So what type of a lens? It's a plano-convex lens. Plano-convex. Sometimes it can also be like this. What is this? Plano-concave lens. They may have a double bulging layer, or if one part can be a plane and the other one can be, depending upon the uses. It's not given in your textbook. Please, somewhere at least if you can quickly, sketch it out. Plano, 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 convex, and a plano concave. One surface is plane, and one is plano convex and plano concave.
No, because one surface
Plane. One surface is plane, therefore it is plano. Don't get confused. But all you come across such things, but don't tell R we don't, because they are mentioned. Okay. Done? Read better.
It is thicker at the middle as compared to the edges. Convex lens converts light rays as shown in figure 9.12a.
Okay, pause. Constantly I'm talking about what is differentiation between convex and concave lens. You already got 2 points. What are the 2 points? Sorry? Diverging and converging. So first point okay, दूसरा regarding the shape. Regarding the shape, bulging edges, thicker in the middle and thinner. It is the other way around for concave. So 2 points are here. Mark it in your textbook because I'll ask you to jot down. Differentiate between convex and concave. Okay, we already have got 1 point and the second point. Read.
Hence, convex lenses are also called converging lenses. Similarly, a double concave lens is bounded by 2 spherical surfaces, covered inwards. Curved inwards. It is thicker at the edge than at the middle. Such lenses diverge light rays as shown in figure 9.12b. Such lenses are also called diverging lenses. A double concave lens is simply called a concave lens.
Okay. Yeah.
A lens, either a convex lens or a concave lens, has 2 spherical surfaces. Each of these surfaces forms a part of a sphere.
Underline. It is a part of a sphere. Okay, each surface is a part of a sphere.
The centers of these spheres are called center of curvature of the lens.
Underline center of curvature, your definitions. Yeah, read.
The center of curvature of a lens is usually represented by the letter C. Since there are 2 centers of curvature, we may represent them as C1 and C2. An imaginary straight line passing through the 2 centers of curvature of a lens is called its principal axis.
Did you underline? Principal axis. What is the principal axis? An imaginary line passing through, yeah, through O and also the two F1 and F2. Next.
The center
I was, sorry, 1 minute. I was just looking. Here it is given. You can use the textbook. Page number 55. Refraction of light. Same thing as what we have done. Vyasa, refraction through the lenses. All the diagrams are also given. This is what we will do. Image formed by a convex lens. All this we will do in the next class. Get your geometry also. Image formed by a convex lens. This is what magnification formula and other things. Okay. I will tell you that. Next. Read.
The central point of a lens is its optical center.
Underline optical center.
It is
What is the letter there for optical center? O. So we have learned C, we have learned O. F will be the same, of course, which is F is what? Focus and focal length. Capital F is what?
Focus.
Focus. And focal length is the distance between?
Principal lens. Pole and the focal.
Yeah. There it is pole, here it will be between O and F. It is between optical center and F. Sanjay? Read.
It is usually represented by the letter O. A ray of light through the optical center of a lens passes without suffering any duration.
Okay. Underline that. Passes without suffering any deviation. What does it mean? Look at the board here. Did you see this line? What is this? Principal axis. It's passing through O. There is no deviation. Suppose I draw a line through O, no deviation. If I pass through O, no deviation. Any line which is passing through O, there is no deviation, right? Because it's exactly on the normal. Understood, no?
The effective diameter of the circular outline of a spherical lens is called its
Aperture.
aperture.
Underline aperture.
Please share.
So what does it mean? Suppose this is the lens, the diameter of this lens is the aperture. We say the aperture of the camera. Okay, so that is the aperture. It can be small, it can be big. So that is its effective diameter. Then,
We shall confine our discussion in this chapter to such lenses whose
aperture.
aperture is much less than its radius of curvature, and the two centers of curvature are equidistant from the optical center O.
Okay, what does it mean? For all practical purposes, we are going to take this sphere and this sphere the same. Got it? Sometimes it can be big and small, then F will be different. But for drawing the ray diagrams, we are assuming that both the spheres are the same, such that your focus or the centers of curvature is equidistant.
Such lenses are called thin lenses with small apertures. What happens when parallel rays of light are incident on a lens? Let us do an activity to understand it.
Okay, has anybody used a lens to burn paper? I'm sure as kids you must have done it. Done it? Okay, so what happens is if you are having a convex lens at home, you have one at home or no? You can try that. Take a clear bottle, take a small bottle, fill it up with water. It can be used as a lens. And stand at a window or wherever it is where you get nice bright sunshine. Put a piece of paper, suppose you put a piece of paper here, keep the bottle or the lens here such that the rays of light are passing through. You'll find that the paper will start burning. What is happening? This is the diagram. Rays of light, and if you keep a piece of paper at the focus, the sun rays are getting concentrated. So the paper is getting heated up, and that is how it is getting burned. Have you followed? So we read there. Paper begins to burn, producing smoke. Put a question mark. We'll ask you for, you're going to explain why it starts burning. It may even catch fire after a while. Why does it happen? The light from the sun constitutes the parallel rays. These rays are converged by the lens at a sharp, bright spot formed of the paper. So which spot is that? At the focus. Okay. In fact, the bright spot that you get is actually the real image of the sun. Okay, the sun, the white spot that you get. The concentration of the sunlight at the point generates heat, and this causes the paper to burn. Did you get your answer? Mark it. Okay, put a Q there. That's going to be one of the questions which is going to be asked. So they are all talking about the ray diagrams, etc. Principal axis, etc. Come to the last line, come to the last paragraph. Who wants to read? Read it, Ani. If you pass parallel rays,
From the opposite surface of the lens, you get another principal focus on the opposite side. Letter F is usually used to represent principal focus. However, the lens has two principal foci. They
foci and focus. What is the difference?
foci is singular.
Plural and focus is singular. Two foci, one focus.
They are represented by F1 and F2. The distance of the principal focus from the optical center of the upper lens is called its focal length.
Underline what is focal length? The distance of the principal focus from O. What is O? Optical center is called the focal length. What alphabet will you use for focal length? Smallest. Correct.
The letter F is used to represent the focal length. How can you find the focal length of convex lens? Recall the activity 9.11.
Okay, 1 minute. We come back to the activity that we have done for burning the paper. Right? Imagine that this is my paper and imagine that this is the lens. I'm keeping it here. Sun rays are coming, paper is burning. How can I find out the focal length of this lens? Jaldi bolo.
Distance
Between the lens and the
paper.
paper. That's it. Very good. Understood? Why? Because the paper is burning. This is your focus. The distance between the lens and the focus. The focal length. Samjha? Put a Q there. Okay, boys, you may read. That is this one.
I just one. The dash is the image of dash.
That is about study the diagram and come to get this one. Then here the angle of incident as angle
just one जलेगा तो है नहीं
what is the image? Dash is the image of dash. So which is the image? You have got this one. What is this Q? O dash P dash will be the image of P and O. That's it. This is the image. No, see here. This is the object, and this is the image. So this is the image of this object. That's all.
Q P is the
Dash P
Dash is the image of this object, which is equal to O.
dash नीचे नहीं ऊपर लगता है. Now we did the same experiment when we went for the father and the mother. So we took a leaf and the speck, and then the sun was so big.
Okay.
Father.
Ah,
So we went for a match. Then we took a leaf and a speck.
somebody specs.
Yeah. So the sun was so big that the leaves started
Working. But somebody's specs will be a concave lens. I'm not sure whether it was a convex.
We had an idea at that time. Like we were just kids. We were in 7th and then
Oh, okay.
7th में last match मैंने 9th की starting में खेला था बस Reliance. Reliance I don't know.
how to use the